Hi everyone, this is Mrs. Poland. We are working on example 2 from lesson 7.11 and we're examining the power of a test. Bottles of a popular Coke are supposed to contain 300 milliliters of cola. A consumer group believes that the company is underfilling the bottles. Assume a population standard deviation of 50 and a sample size n of 30. Find the power of the test against the alternative that mu is equal to 200 milliliters. Assume a significance level of 0.05. So we start by defining our null and alternative hypothesis. So our null is that mu is equal to 300 milliliters against the alternative. Well, the consumer group feels that they're underfilling the bottles, so the alternative is mu is less than 300 milliliters. So if we were to mark up our sampling distribution for this scenario, or for the null, our mean of the sampling distribution would equal to mu, which would be 300, and the standard deviation of that sampling distribution would be sigma x bar is equal to sigma over square root of n. So in this case, it would be 50 over square root of 30. And if you enter that into the graphing calculator, that's about 9.1287. And let's mark up the distribution. So the sampling bit distribution for mu equals 300 would be the one to the right, because it would have a higher mean, so it would be shifted to the right. And we normally notate it mu sub 0. And the one that I'm marking up in this bluish royal blue color, I like royal blue, would be the sampling distribution of the alternative. So the mean of that, and we'll represent that with mu sub a, and that would equal to 280. Now, there is some sort of value, and I'll make this into a dotted line. So let's find a dotted line. There's some sort of value that you're going to reject the null at, and so let's pretend that it's here. And anything to the right of that line, you're going to fail to reject. And anything to the left of the line, you're going to reject. So let me get a highlighter out, and I'm going to make it pink this time. So in this region that I'm coloring here, I'm not doing a very good job coloring it, that represents your type 1 error, and that in this case is going to equal to 0.05. Actually, I'm going to recolor that. Hold on. Thank you. It was a little bothered. It was a little sloppy. Okay, so anything in this highlighted pink area is your rejection region, and the probability of making a type 1 error, that is when you reject the null when the null is true, would be in here too, and that the chance of that happening would be whatever your significance level is, which in this case is 0.05. So the probability of the type 1 error, which I'm going to write here, is equal to alpha, which is equal to 0.05. We can find the value that occurs at, and we're going to do that because we need that in order to calculate beta and power. So to calculate that sample mean, where that cutoff happens, you're going to use inverse norm. Remember, we're going to be using a population standard deviation, so we can use inverse norm. And in this case, since it's left-tailed, we're going to use the 0.05 percentile. The mean would be 300, and the standard deviation would be the 9.1287. And so let's enter that into the calculator. And we get 284.985. If I want to calculate beta, the probability of making a type 1 error, well, let's think again what a type 2 error is. A type 2 error is when you fail to reject HO when HO is false. Since HO is false, right, since that's what we're looking for, the mean that we're going to use is the alternative of 280. And we're going to be in that fail to reject region. So what are we really looking at? So I'm going to highlight that, and let me highlight that in, I'll highlight it in blue. Actually, I better use the lower blue. So you're using this blue distribution, the one with the royal blue outline. And so you're really looking in this region, the fail to reject, but just in the region that I'm highlighting. And we're going to call that beta. And to calculate that, we're going to use Normalcdf. The low end is going to be the 284.985. We're going to go all the way to the right. The mean of that distribution is going to be 280, and we're going to use the same sampling standard deviation of 9.1287. So let's enter that in the calculator. Oop. Let's try this again. Six distribution. My computer's being very sensitive today. So this is 284.985 and 9E999, and the mean of 280, and again we're assuming the same population standard deviation. And when we do that, we get an error of 0.293. So that's the error of when you fail to reject when the alternative is, when the null hypothesis is false. So what is the power of the test? So let's think of it again. We'll make power green. Power is the probability of correctly rejecting HO. And let me get out the yellow highlighter so you can see it. So we're saying that HO is false, and we're going to reject it. So you're going to be on the left side of this line, because again, we're looking at the left tail situation. So it's going to be anything in here. And I better get a thicker marker out. So anything in this area, even in that, like that orange, I guess, pink and yellow make orange. I forgot about that. should know that. That's from like elementary school, right? So including that shaded region here, this whole thing represents the power of the test. And to get the power of the test, the easiest thing once you have beta is just to subtract from 1. So it would be 1 minus 0.293, and that's equal to 0.707. And just, basic rule is that a power of 0.8 or higher is considered very good. So 0.07 is not bad. It's not perfect, but it's not bad. And I hope you have a better understanding of what power is. Again, you're not expected to do the actual calculations on it, but you should be able to identify from a graph what region is an alpha, what's the beta, and what the power is. And if you're given the value of the type 2, you should be able to calculate the power by going 1 minus, and vice versa. If you're given the power, you should be able to go 1 minus power to get the probability of a type 2 error. One last thing. On the AP exam, they do expect you to be able to interpret power in the context of the problem, as well as a type 1 and a type 2 error.